Assalamu alaikum dear cadets. Welcome to Borishal Cadet College online class program. Due to coronavirus, our regular classes are not being held. But life will not stop. We must keep moving on. So that I am here to take your class virtually. I am Mohammad Kamaluddin Monir, lecturer in mathematics, Borishal Cadet College. Dear cadets, be aware of coronavirus to prevent coronavirus. You must wash your hands and use mask when you are outside. Today, I'll take a class topic probability. This is a revision class and it is chapter 14, higher mathematics. Learning outcome. After studying this chapter, students will be able to explain the concept of probability, describe certain events, impossible events, and possible events by giving daily life examples. Describe the consequence of repetition of an event. Find the probability of an event happening repeatedly. Solve simple and real life problems regarding probability. Now, how likely something is? Probability is how likely something is to happen. You might also hear it called chance. Probability can be expressed as fractions, decimals, or percentages, or on a probability scale. Now, what is probability? Probability or chance is how likely something is to happen. If something has a low probability, it is unlikely to happen. If something has a high probability, it is likely to happen. Now see the figure. This is a spinner. Geeta has this spinner. What is her chance of spinning the numbers in the boxes below? Match his box to the correct word. One has done for you. An odd number. Even chance. 2 and a number less than 10. So chance to get 2 is impossible. A number less than 10 is certain because here four numbers are present: 4, 5, 3 and 6. Therefore an odd number, an even chance. 2, here is no 2. So getting 2 is impossible and a number less than 10 is certain because these four numbers are less than 10. The language of probability: certain, very likely, even chance, not likely, and impossible. Certain. The sun rising tomorrow. It's an certain event. Even chance. Getting tails when you toss a coin. 50-50 chance. Not likely. Rolling a 6 on a dice. Impossible event. Rolling an 8 on a dice. It is impossible. You can spin any number from 1 to 6 on this spinner. Write a number that is impossible to spin. 1, 2, 3, 4, 5, 6 are the number. Here is another figure. Striped, spotty, white and grey. These marbles are hidden in a bag. The bag is shaken. Petey pulls out one marble without looking. Which kind of marble is Petey most likely to pull out? Next, explain how you know. Now see. A number less than 1 or greater than 6 is impossible to spin. White. Your answer is white because there are more white marbles than any other color. Now, how to express probability? Probabilities are most commonly shown as fractions. The probability of getting tails when you toss a coin is 1 in 2 chance or 1 by 2. The probability of getting a 3 when you roll a dice is a 1 in 6 chance or 1 by 6. Can you tell me what the probability is as a fraction? What is the probability of rolling a 4 with a dice? What is the probability of rolling an odd number with a dice? A bag contains 7 buttons. 3 of them are green. What is the probability of picking a green button from the bag? Question number 4. A bag contains 3 red and 5 green marbles. What is the probability of picking a red? First question. What is the probability of rolling a 4 with a dice? Answer is 1 by 6. Second question. Odd number with a dice. 3 by 6 or 1 by 2. And answer of third question. 3 by 7. And answer of number question 4. 3 by 8. Because there are 8 marbles and 3 are red. Therefore, picking a red, probability of picking a red is 3 by 8. How to express probability? Probabilities can also be shown as decimals or percentages. A probability of getting tails when you toss a coin is 1 in 2 chance or 1 by 2 or 0.5 or 50%. A probability of 3 by 4 can also be shown as 0.75 or 75%. Can you tell me what the probability is? What is the probability as a decimal of getting heads when you toss a coin? Something that has an even chance of happening has a probability of what percentage? Question number 3. A bag contains just 5 buttons, all of which are blue. What is the probability of picking a red button from the bag? Now, question number 4. A bag contains 4 white buttons. How many black buttons must be added so there is an even chance of picking a white button? Now answer. Getting heads when you toss a coin is 0.5. Question number 2, 50%. Question number 3, 0. Because there is no red button. And question number 4 is 4. Now, how to work out probability? Work out the probability of throwing an even number on a dice. Count up the total number of possible results. When throwing a dice, for example, there are 6 possible numbers. The dice can land on 1, 2, 3, 4, 5, 6. 2. Then count up the number of results you are interested in. In this example, you are only interested in throwing 2, 4 or 6, all the even numbers on a dice. So you are interested in 3 numbers. The probability of getting an even number on a dice is 3 chances out of 6 chances, which you write as 3 by 6. Probability scale. 1. The sun will rise tomorrow. Impossible, unlikely, even chance, likely or certain. Just think. You will live to be 500. 3. You spin a coin and get a head. You will see a bus on your way home. You will see an ambulance on your way home. Now, the answers. 1. The sun will rise tomorrow. This is certain. You will live to be 500. This is impossible. You spin a coin and get a head. Even chance. You will see a bus on your way home. Likely. You will see an ambulance on your way home. This is unlikely. Now, a creative question. This creative question is very much important for your exam. Some tickets are numbered serially from 41 to 60 in a box. One ticket is drawn at random. Question A. Find the probability of getting an odd number or a number divisible by 2 in a single throw of a dice. Question number B. Find the probability that the number of the ticket will not be divisible by 2 and 3. C. Show that the sum of the probabilities that the number of the ticket is prime and divisible by 2, 3 and 5 is a real fraction. Now answer. Answer of A. Here total number on a dice equal to 6. That is 1, 2, 3, 4, 5, 6. Total number of odd numbers on a dice equal to 3. That is 1, 3 and 5. Total numbers of numbers divisible by 2 equal to 2. That is 2, 4, 6. Total number of number divisible by 2 equal to 3. That is 2, 4, 6. Therefore, probability of getting an odd number or a number divisible by 2 in a single throw equal to total favorable outcomes divided total possible outcomes. That is 3 plus 3 by 6. That is 1. Now, answer is 1. Now, question number B. From 41 to 60, there are 20 numbers in total. Again, from 40 to 60, the numbers not divisible by 2 and 3 are 41, 43, 47, 53, 59. That is 5 numbers. Will not be divisible by 2 and 3 equal to 5 by 60 or 1 by 12. Therefore, answer is 1 by 12. Now, answer of question number C. From 41 to 60, prime numbers are 41, 43, 47, 53, 59, which are 5 in numbers. And total number from 41 to 60 is 20. Therefore, probability that the number will be a prime number equal to 5 by 20 or 1 by 4. This is equation number 1. Again, the numbers which will be divisible by 2, 3 and 5 simultaneously is 60. Probability of getting the number divisible by 2, 3, 5 simultaneously equal to 1 by 20. This is equation number 2. Now, sum of 1 and 2 is 1 by 4 plus 1 by 20, which is equal to 3 by 10, which is a real or proper fraction. Now, another question. Two unbiased dice are thrown together. Question number A. Draw the probability tree of the event. Question number B. Find the probability from the sample space of those sample points whose sum of two digits are at least 9 each. Question number C. Find the probability from the sample space of those sample points whose sum of two digits are not 6 or 11 each? Answer of A. A probability tree of possible outcomes of throwing of two unbiased dice is drawn below. Faces of dice are 6 and one dice, and every dice is thrown for 6 times. That is probability tree. Now, question number B. A sample space of outcomes known as sample point due to throwing of two unbiased dice is found taking under consideration of the probability tree drawn in A as under 1 1 1 2 and such way 6 6, last of 6 6. Now, from the sample space, it is observed that the sum of the digits of the following numbers is are encircled are at least 9 each. These are 36, 45, 46, 54, 55, 56, 63, 64, 65 and 66. It is also observed from the sample space that number of total sample points outcomes of experiment equal to 36 and the number of sample points for whose individual sum of digits are at least 9 is equal to 10. Therefore, record probability of those sample points whose sum of two digits are at least 9 equal to 10 by 36 or 5 by 18, and it is our record answer. Now some extension activity. You are going to toss a coin in the air a total of 30 times. Every time the coin lands, you are going to record whether you get a head or a tail. Write Ace for head and tail, T for tail in the table below. How many times did you get a head, Ace? How many times did you get a tail? This is your activity. Another activity. You are going to roll a dice a total of 30 times. Every time you roll, you are going to record the score on the dice. Write the score you get each time in the table below. Number of 1, number of 2, 3, 4, 5 and 6. Now dear cadets, homework. An unbiased coin and an unbiased dice are tossed and thrown together once. First question, if the dice is thrown once rather than the coin, determine the probability of getting a prime number on the upper side. Number B, draw the probability tree and write down the sample space and then determine the probability of getting the head of the coin and an even number of the dice. Number C, if two dice are thrown once together, then draw the probability tree and find the probability of getting same number on the upper side from the sample space. Now dear cadets, if you have any question, you can ask me through comment section. Dear cadets, be aware of coronavirus, therefore stay home and remain safe. Thank you.